This is problem number 24. It says, in which one of the following structures, as drawn, does the central atom have a formal charge of +2? So when we're talking about formal charge of the central atom, what we're going to have is, there's this formula here. Formal charge is the starting number of electrons minus the valence electrons minus the number of bonds attached to it. And you're going to get the starting number from its position in the periodic table. So for example, carbon is in the 4th row. It's in row 4. So if it has 4 things attached to it, like 4 hydrogens, you're going to have the starting number is 4 minus the valence electrons, there aren't any, minus 0, minus the number of bonds attached to it. So 1, 2, 3, 4. 4 minus 4 is 0. So the formal charge on this carbon is 0. Okay? So let's start looking at these structures that they give us. So part A. They give you a sulfur with 6 fluorines on it. So, if you look for sulfur in the periodic table, you'll see that it's in the 6th row. So our starting number of electrons is going to be 6. Okay? Minus the valence electrons on that sulfur. There aren't any. So minus 0. Minus the number of bonds. There's 6 bonds because it's attached to 6 fluorines. 1, 2, 3, 4, 5, 6. So minus 6 equals 0. So the formal charge on this sulfur is 0. We're looking for one with positive 2, so our answer is not going to be A. Okay? Part B. They give you a sulfur with 4 oxygens attached to it. Okay, and for I'm just going to draw these lines for lone pairs. So, again, the starting number of electrons is 6, because it's in the 6th row. There are no valence electrons on sulfur. We're not talking about the valence electrons on the oxygens here, we're only concerned with the sulfur. And there's no valence electrons there. Minus the number of bonds attached to it, there are 4 bonds, so this sulfur's formal charge is indeed 2. So our answer is going to be part B. I'll do one more just so you can get another idea of formal charges. So, part C is this structure. It's an oxygen attached to, double bonded to an oxygen, and single bonded to a third. So oxygen is in the same row as sulfur, so we're going to start with 6, minus the number of lone pairs on this oxygen is, well, it's the number of valence electrons, so 1, 2, 6 minus 2, minus, how many bonds do we have? 1, 2, 3. The double bond counts as 2. So 6 minus 2 minus 3 is 1. But that's not our answer. Like I said before, the answer is B.